Okay, let's try sine of 2 theta equal 1/2. This seems a little bit different than those other linear trig equations we were doing, but how hard can it be, really? Let's take a look. So we're going to take inverse sine of both sides. 2 theta equals sine inverse of 1/2. We're going to take a look at our triangles. Sine is positive in the first quadrant and also in the second quadrant. So my angles then are going to be pi 6, and that's that one, and this one is going to be 5 pi 6. And then dividing both sides by 2, I get pi 12ths and 5 pi 12ths. Or maybe what we do is we go from here, we try something like this, where we get 2 theta is sine inverse of 1/2. So 2 theta is pi 6. So theta sub r, our reference angle here, is going to be pi 12ths. And I look at my triangles, and I've already found one solution is pi 12ths. And then the other one is going to be pi minus pi 12ths. And that is, of course, going to give me pi 12ths and 11 pi 12ths. So, well, these both seem like reasonable approaches. Certainly they both can't be right. Sir, why don't you try looking at the graph? Yes, that is a great idea. I am always telling you guys to consider both algebraic and graphical approaches to the problem. I should really listen to my own advice. Okay, so let's take a look. What does that look like? Sine of 2x. Okay, here is sine of 2x, and here is y equal 1/2. Hold on a second. 1, 2, 3, 4. 4 solutions. Oh, this is troubling. This is very, very troubling. So that means this is wrong. Well, now that is a bummer. Okay, let's try this again. So we take sine inverse of both sides. That seems like an obvious thing to do to me. I think maybe my problem was that I had it in my head there's always 2 solutions when you have an equation like this between 0 and 2 pi, because that always seems to be the case. But apparently that is not always the case. So let's take a look. Well, let's right now consider all of the possible angles, and there are an infinite number of angles whose sine is 1/2. And again, I can go back here and look at my triangle, and I can go, here's one of my triangles right here, which generates a pi 6, and here's the other second quadrant one, which generates 5 pi 6 as the angle. So we're looking at pi 6 plus any rotation of 2 pi in either direction, or multiple of 2 pi around, will get me to another angle that is coterminal with this pi 6. Okay, and I can do the same thing with 5 pi 6. And again, where n is an integer, n is an integer. Okay, now these are the infinite number of solutions for 2 theta. So now what I'm going to do is I'm going to divide both sides by 2, and that is going to give me pi 12ths plus pi n, where n is an integer, and that's going to give me 5 pi 12ths plus pi n. Oh, okay, this is starting to make some sense now. I see. Normally, sine has a period of 2 pi, but it's been horizontally compressed by 2, so the period now becomes pi. That makes good sense. Okay, so then These are the infinite number of solutions to theta on an unrestricted domain. Problem is, our domain is between 0 and 2 pi. So we can only consider the solutions that are between 0 and 2 pi. So pi twelfths is certainly between 0 and 2 pi, as is 5 pi twelfths. And then if we add pi to pi twelfths, we end up with 13 pi twelfths. And if we add pi to 5 pi twelfths, we end up with 17 pi twelfths. And that is 4 solutions. Okay, great. I'm feeling much better about this now. Let's try something a little different. This time we're going to try U substitution, because U substitutions are cool and because they make me feel smart. So we're going to let U equal 2 theta. So my new equation becomes sine of U equal 1/2. And trig equations don't get much easier than that. Now here's the thing, my domain is still in terms of theta. So I need to put it in terms of U. If I multiply through that inequality by 2, I get 0 is less than 2 theta, less than or equal to 4 pi. And since U is equal to 2 theta, I get a new restricted domain. 0 is less than U is less than or equal to 4 pi. Now when I solve this equation, we do our reference triangles again, and this is looking very familiar, I'm sure. 1 and 2, and this is, of course, pi 6, and this one is, of course, 5 pi 6. But that's just between 0 and 2 pi. U has a domain that is between 0 and 4 pi. So I have to consider the fact that I need to add an extra 2 pi on top of pi 6. So I have my pi 6, I add 2 pi to that, and that's going to take me to 13 pi 6. And then I take my 5 pi 6 and I do another full rotation on top of that, and that's going to take me to 17 pi 6. And those are my 4 solutions for U. But no one asked me about U, so I am now going to substitute my 2 theta back in, and I get 2 theta is equal to pi 6, 5 pi 6, 13 pi 6, and 17 pi 6. And now I just divide both sides by 2, and I get theta is equal to pi twelfths, 5 pi twelfths, 13 pi twelfths, and 17 pi twelfths. Okay. And those you'll recognize as the exact same 4 answers we got just a second ago. All right, I am starting to feel really confident now. Let's take a graphical approach this time. What do you say? For this approach, we're going to solve it using inverse operations as if we're just using a calculator and we only want the one solution. So 2 theta is equal to sine inverse of 1/2. 2 theta is equal to pi 6, which is what the calculator would give us if it could give exact values, and then theta then becomes pi twelfths. Okay, now that is the first solution on this graph, and that can be represented with this intersection point right here. I'm going to get rid of this line y equal 0.5 for now. And so what you know is you know the distance between the y-axis and that first solution can be represented by this little length right there, and you know the distance is pi twelfths. So now what we're going to do is we're going to use the symmetry of this sine curve. I know the distance from the next solution, which is here, to the line x equal pi halves, okay, can be represented by that, and that's going to be the exact same distance. So I know all I have to do for that second solution is do pi halves minus pi twelfths, which is going to be 5 pi twelfths. So moving on to that third solution. That third solution is going to be just pi twelfths past pi. So theta is going to be pi plus pi twelfths, and that is going to give us 13 pi twelfths. And then that last solution right there, which can be represented like so, is going to be just pi twelfths short of 3 pi halves. So we can do 3 pi halves and subtract out pi twelfths, and that is going to give us 17 pi twelfths. And there you go. 1, 2, 3, 4 different solutions. And they're exactly the same as we got the last two ones that we just did. And we probably should have used subscripts to show these 4 different angles here. Theta sub 1, theta sub 2, theta sub 3, and theta sub 4. So this wasn't nearly as hard as I thought it was going to be. Sir, what if it had been 3 theta instead of 2 theta? That's a great question. All right, let me get rid of some of this. Okay, if it had been a 3 theta instead, okay, then what would have happened is your graph wouldn't look like that. Your graph would look like, here's 1/2, and 3 theta looks like this. And because it's a compression by 3 this time, it does 3 full cycles between 0 and 2 pi. Hence, you have 3 times 2 solutions is 6 solutions. And you can find them in any of those last 3 ways we just demonstrated. Thanks for listening. Now go do some practice.